All right, let's dive into something that trips up a lot of people, even those who work with data all the time. We're going to look at a super handy tool that helps make confusing comparisons, well, a whole lot clearer.
So here's the big question I want you to chew on for a bit. Is a bigger spread always a bigger deal? You know, when you see a wider range of numbers, does that automatically mean there's more inconsistency, more risk? The answer isn't as obvious as you might think.
Okay, so our story begins with a classic problem, a real headache when you're looking at stats. It's that whole apples to oranges thing, right? Trying to compare two things that are just on totally different levels. And believe me, it can lead you way off track if you're not careful.
So let's get specific. Here's the puzzle for today. We've got a company's monthly numbers for two things, their electricity charges and their direct wages. The question is simple. Which one is more, well, variable? Which one jumps around more unpredictably from month to month? Okay, let's put the actual numbers up. On one side, we have the average electricity bill, which is 2,400 rupees. Then you've got the average wage bill, and that's way bigger, 42,000 rupees. Now look at the spread, the standard deviation. For electricity, it's 120. For wages, a whopping 1,200. Just looking at that, what's your first instinct? What's your gut telling you?
Yeah, to figure that out, most of us would immediately look at something called standard deviation. It's kind of the default tool, the first thing you reach for to see how spread out your data really is.
And all it really means is this. A bigger standard deviation just means your numbers are, on average, further away from the center, from the mean. It's our first big clue about variability. It's a really powerful tool, for sure. But, and this is a big but, it has one little weakness that can really throw you off.
So let's focus on this number right here, 1,200 rupees. That's the standard deviation for wages. I mean, it is 10 times bigger than the 120 for electricity. So, case closed, right? It seems so obvious, wages are way more variable. But are they, really?
And this is where the story takes a turn. Just staring at that big number, that 1,200, it's a trap. It's a total trap. Because we're completely ignoring a huge piece of the puzzle. The scale of the original numbers.
Think about it. A 1,200 rupee swing means something totally different when you're talking about an average of 42,000 compared to an average of just 2,400. It's like a $10 change in your lunch budget feels a lot different than a $10 change in your rent, right? It's not a fair fight.
So what we really need is a way to get some perspective. We need a tool that can look past the raw units, the rupees, and just give us a pure number, a percentage, maybe, that lets us compare these two things on a level playing field.
And this, my friends, is where the hero of our story makes its grand entrance. It's called the coefficient of variation, or CV for short, and its whole job is to level that playing field.
The real magic of the CV is right there in what it is. It's a pure number. It doesn't care about rupees or dollars or inches or pounds. It's basically a percentage. And that's what lets us finally truly compare the variability of completely different things, like a small utility bill and a giant payroll.
And check out how simple it is. This little formula is our great equalizer. All it does is take that spread, the standard deviation, and it looks at it in relation to the average. It puts it into context. See? It's all about perspective. All right, we've got our mystery, we've got our secret weapon. Let's put this thing to work and solve this thing once and for all. It's super simple, just 2 steps. First, we'll calculate the CV for the electricity charges. Then, we'll do the exact same thing for the wages. Okay, electricity is up first. We take its standard deviation, that's 120, divide it by the average, which is 2,400, and then times 100 to make it a percentage. And what do we get? Boom, 5%. Okay, now for the wages. We take that big, scary 1,200 standard deviation, but now we divide it by that huge average of 42,000, and the result is, wait for it, only 2.9%. Wow!
And there you have it. That's the answer. Isn't that wild? Even though the raw number for the spread was way smaller, the electricity charges are actually more variable in a relative sense. Our first impression, our gut feeling, totally, completely wrong.
So, what's the point of all this? Well, it's not just a cool math trick. It's a really important lesson about perspective. It shows you why picking the right tool to look at your data is just so critical.
And the rule of thumb couldn't be easier. A higher CV means higher variability, period. It doesn't matter what you're comparing. You could be looking at the price of houses versus the price of coffee, or a person's heart rate versus their body weight. The CV gives you a common ground to stand on.
And this really puts everything in perspective, right? There are other ways to measure spread, sure, like the range or mean deviation.
And don't get me wrong, standard deviation is a powerhouse. It's amazing for most things. But it has this one blind spot. And for our specific apples to oranges problem, the CV was the only thing that could show us what was really going on.
And really, that's the whole point. The next time you see a comparison that feels off, remember the coefficient of variation. It's a great reminder that sometimes, to find the real story hiding in the data, all you have to do is change your perspective. So I'll leave you with this. What hidden truths could you uncover if you just looked at them in the right way?